Yes, we can.
Cool. All right. So, hi everyone. Let me just set this camera properly. Okay. So, thanks for taking our time to join us today, and I'm super excited to be here. And I'll be talking about writing a research paper, your first steps, things you need to do, and stuff like that. So, without wasting much time, I'm going to go straight to the slide. So, I'll just share my screen. Can you still see me?
Yes, we can.
Okay, cool. So I'm just going to go straight to the slide. You should be able to see my screen now, right? Okay, so, all right. So once again, you're welcome to the virtual conference. And just a minute, Okay, yeah. All right, so the title of this presentation is Writing Your First Research Paper, okay? And my name is Rising Adegwa. I'm a data scientist and researcher at Data Science Nigeria. And you can see my Twitter details, my email details, in case you want to reach out to me. I'd love to chat. I like talking about things related to data science, artificial intelligence, machine learning, and research in general. So if you love stuff like that, you can always chat me up. All right, so let's go straight to the point. The next slide. All right. So overview of this talk session, we're going to talk about what is research, types of research, the research process, the research in data science, AI, and machine learning, then advice for new researchers, publications, and then some final words. Okay, so let's go straight to the point. So what is research? So research is basically a systematic work undertaken to carry out, or to the end goal is to get most of these outcomes. One is increasing stock of knowledge, devising new applications, establish or confirm facts, to reaffirm the results of previous work, and also solve new existing problems, support theorems, and develop new theories. So basically, research is just trying to improve human knowledge. Because if, for example, you have different applications, you have different problems in the world today, if you want to increase human knowledge in it, or you want to provide solution to these things, you have to first of all carry out research. So research is simply a way of trying to increase, or is a systematic way of increasing knowledge, trying to devise new application. Because, for example, if you have like in the case of the COVID-19 stuff that we're currently experiencing, lots and lots of research are currently ongoing to be able to help, bring out new ideas, or bring out a vaccine, or bring out a cure to the COVID-19. So researchers and scientists are currently working on it 24/7. So what are they trying to do? What is their outcome? They are trying to provide solution to it. And for them to provide solution, they have to carry out this research. So it's a systematic study. So research is not just for maybe the medical field, it's for every field. Even people who do design, they carry out research. What do my customer want? People who build websites, people who build applications, people who do data science, people who do marketing. So in all fields, for you to be able to improve or move to the next level, you must carry out research. Please, as I'm talking, if you have any questions, you can just type them using the live chat. After the session, I'm going to go through them and I'm going to answer most of the questions. Okay. So basically, that is research. All right. So what are the types of research we have? We have basically two categories. We have basic research and we have the applied research. So basic research is just, the aim is just to improve the theories and help us improve our understanding of natural phenomena. Okay, so there's no applied work there. There's no practical work there. It's just trying to improve scientific theory behind why most things work. Okay, that's why you see many papers are about trying to justify the mathematical justification behind applications, behind solutions, behind theories that people have proposed. People are trying to justify them, trying to understand them better. That is kind of like a basic research. Then for applied research, you are using those scientific theories which you've gotten from basic research to develop new technology. Okay, like for example, here we have GAN, Generative Adversary Network. Okay, people who apply this research, people who use these particular tools to come up with new applications are doing what we know as applied research. Okay, so basic research normally fuels applied research. So if people need to do the basic research first, get the theories, understand the mathematics or the low level details behind a particular concept, then people take this concept and this understanding and use it to build new technology. Okay, so that is that. Then for the next one, types of research. So we have original research, we have scientific research, artistic research, humanities research. So I think the audience for this festival is mostly people who are into data science, artificial intelligence, and the rest. So we normally carry out mostly original research and scientific research. Okay, so original research is not based on existing or a summary of previous knowledge. This is normally more difficult. Okay. Someone is saying I can't hear. I think you have to maybe increase your volume. So just try and increase your volume. All right. Emeka.
Yeah, I'm with you.
Okay, good. All right. So for original research, it is not based on previous knowledge. So when you come up with novel ideas, novel discoveries, novel inventions, this is when you talk about original research. Okay. So this is usually more difficult. It takes because most of the things that we discover, most of the research are actually built on existing work. So for you to come up with original research is very, very difficult. You have to think maybe far and outside the box. Okay. So then for scientific research, it's practical application of research that is possible. It provides scientific theories for the explanation of nature and properties of the world. So when I talk about nature and properties of the world, when you're just talking about earth or geography and stuff like that, we're talking about everything that makes up the world. So it can be computers, it can be buildings, it can be anything. So once you take out these ideas and you carry out research in them, you can actually try to explain or improve the way they work. Okay. Then you also have artistic research and humanities research, which I'm not going to dive deeply into. Okay. So because of time. So let's move to the next one. All right. So what is the research process? Now the research process normally has like these are steps that you follow. Though it is not a law, you don't have to follow it from end to end. Sometimes it can be iterative. You can go back, go forward, but most of the time this can guide you into doing your research. So the first one is to identify the problem. So I'm going to use my pointer. Okay, so the first is to identify the problem that you want to solve. So whatever field you may be in, if you are doing machine learning, if you are doing data science, if you are doing just prediction, whatever field you are in, even if you are doing web development, design, the first thing is to identify a particular problem that you want to solve. Okay, so, for example, you see that, for example, you do biology in school or you do biotechnology in school, and you see the problem that's happening currently with the COVID-19. So, you've identified a problem. So, what do you want to come up with? You want to come up with a solution. You want to come up with a cure. You want to come up with a vaccine. Okay. So, I'm just using biology as an example. There are other things that you can, other fields as well that you can do. So, the first thing is to identify the problem. So after identifying the problem, you review existing literatures and solutions that are surrounding that problem. So what have people done before? Okay, so if you know the problem you want to solve, what have people done already in this field? So you look for research papers, you look for applications, you look for other solutions, and you try to read up on them, see how people approach this problem, see what they've done. And during this process, you are taking notes, you are taking references, and you do other. You can even call up people who have done works on this. You can call them, you can chat up them and like, how did you approach it? What have you done? So during that process, you can now see if solutions have been made and how you can improve those solutions or how you can come up with a new solution from what has been done before. So you review existing literature. That's another step. Then from there, you move on to, you narrow your focus of the research because in the reviewing of existing literature, you're actually going to read very wide. You're going to read different topics, different solutions, different things. So you're going to be reading like very wide on a broad level. on an horizontal level. So after doing that, you narrow down your focus to a particular place or to a particular idea or to a particular solution. Okay, so now you have the bulk of knowledge behind you. You have this knowledge of existing literatures behind you. So from that existing literature, you can narrow down your idea to a single focus, because research that is not focused on a single idea is not going to do well, because you're trying to solve too many things at the same time. So the best thing is to narrow down your focus. Okay, so the next step is to narrow down your focus. Then the next step is to specify a framework and form your hypothesis. So for example, framework are like the tools that you are going to be using. So for example, if you want to carry out research in data science, what tools will you be using? Will you be using Python? Will you be using R? Will you be using Java, C++? What libraries are you going to be using? What framework? So that's just the framework you are going to be using. So you specify what tools you are going to use. Then after that, you form your hypothesis. Your hypothesis is like what you are trying to prove. Okay, so for example, maybe you are trying to say neural networks perform well when you have large data. So that can be your hypothesis. Although that's something people have already done in the past. I'm just giving an example. So that can be your hypothesis. So maybe you are trying to carry out research to prove this hypothesis wrong or right. Okay, so you specify your framework, form your hypothesis. Then after that, you collect data and verify the data. So now you're trying to collect data to be able to answer your questions. So for example, like the example I gave earlier, yeah, hello, any problem? Okay, I think we're good to go. I was hearing some sounds. All right, so the data you collect is trying to prove your hypothesis, that if it is correct or if it is wrong. Okay, so you collect data that is related to what you are trying to prove, what your research is about. Okay, and during the process of collecting data, you have to follow ethical guidelines, ethical rules. Don't falsify your data. We'll talk about that later. And the next step is to analyze and interpret the data. Okay, so you've collected the data. Now you want to answer a particular hypothesis. So you have to analyze and interpret that particular data. Then finally, after doing that, you get your results and the rest. So the next part, which is one of the most important parts, is to report and communicate your findings, because you can't carry out research and keep it in your computer. No, you have to put it out there. People have to criticize it, people have to critique it, people have to look at it and say, okay, this is good, I can apply it. So you have to report and communicate your findings. So this is basically the research process. So it is not linear, it is iterative, because sometimes you can collect data and you see that data is not enough or it does not answer your question. You can go back and do that again. Your focus can change sometimes depending on what your study is about. So this process is kind of iterative. Okay, it's not fixed. All right, so that is basically the research process. So moving on to the next one. Now, doing research, we are coming down to now AI and data science, things that are related to what we are doing. Okay, so now doing research in AI and data science fields. What are some of the tips and things that you can put in mind to do this? Okay, now meanwhile, I think I should clear an idea. I think most people feel doing research is just for people who are in academia, or people who want to, for example, do a master's degree, then do a PhD. No, no. Research is basically part of your everyday life as a data scientist, as an AI engineer. You basically do research every day. For you to carry out analysis, trying to solve a problem, you have to do some research. I think the only difference is that most people don't document their results. Okay, so if you, for example, you got data from Twitter, for example, and trying to maybe predict sentiments of tweets, that process of getting the data, trying to predict using particular tool, you are already doing research. The only difference is that you are not documenting your results. You are not following the how would I put it? You're not documenting your results. That's just it. Okay, so basically everyone is kind of doing research in their own way. So if you are doing a cool project, if you are doing anything, you are already doing research, just for you to put it down and share it out there. Okay. So some of the tips. Now, these tips are mostly gotten from Cora and from this Jan LeCor, is the director of AI research at Facebook. It put out a very good outline of some of the things that you consider for you to get started in research. Okay. So some of them, I'm just going to read some of them because of the time. The slides that will be shared, so you can always go through them. The links are there. So he said you should for some ideas that you can take, say take AI related problem you are passionate about. Don't try to solve every problem. So if it's if it's computer vision you are passionate about, stick to it. Read up works and research that have been done on it and try to come up with your own solution. If you are concerned about NLP, do the same thing. So take a problem, take a related problem and the part that you are passionate about. Think about it on your own. Once you have formed your own idea, start reading literatures, like we said earlier. Start reading literatures on it, research papers on it. What have people been doing? Start doing that. Then you will not find that maybe your ideas was a bit naive or your view of the problem is different from what has been done. So when you start following these steps and these steps, you start now getting an idea of what needs to be done. Because an example is me, if I'm using a particular library or I'm using a particular tool, I like to look at some of the defaults, some of the faults in it, some of the things that I need that are not in that particular tool or in that particular library. So from these, I cannot carry out research and say, okay, what are there alternate solutions to this? Have people done this? Have people done this before? So from there, I'm trying to like form an idea of what I can work on. So you see that the more you read research paper, the more you follow people who do these works in the particular field you are interested in, you start seeing loopholes and places where you can come in and offer your own solution in most of this existing research out there. Okay, so you can take advantage of these things. So this is kind of long, so but I'm going to leave it there. Just going to take one last one. Say before you graduate, try to write a paper about your research or release a piece of open source code. Very important. I think this really helped me. Before I graduated, I have written like 2 papers, and I have a professor in my school that I was very fond of, that we're always together, and helped me build my research skill. I helped him research on papers. I helped him review people's work, and that really helped me. So before graduating, I already had like 2 papers out there. So I was already familiar with the process of carrying out research, from getting data, forming your hypotheses, and the rest. So if you are in school, you can start doing your research currently. Take your final year project very serious, because my final year project was on DataSys. DataSys is a library for is data analysis. That was my final year project. I took advantage of it and I made a research paper from it, and I made an open source library from it, my final year project. And I know it has really helped me a lot because it has opened many doors for me. People have reached out to me and the rest. So if you are in school, it's very important that you take advantage of that time. At least before you graduate, get at least 2 papers out there. Okay. So it's very important. Or write an open source code. Okay. But if you have graduated, you can also do the same thing. There's no harm in trying. It's not too late. You can always still do the same thing. Okay. So the next one, continuation from this, Yann LeCon was giving us tips on getting started. So I'm going to leave these ones for you. If you don't get, okay, they say you should apply for research scientist position, AI residency, research interns. There are lots of things that you can do. This is also another advice from Bando Miranda, member of MIT. He said, my advice is to learn the principles of machine learning in general first. Very important, because if you are going to be doing research, you need to know the base. You need to know the basics of these things. So try to implement most of these things from scratch. Stop you maybe, for example, you can try to implement neural network from scratch, logistic regression, linear regression. So these basic things will help you form an understanding of what you are trying to do. So from there, you can now like bring new ideas and ways. Okay, so I'll leave that. I also have another one there. They are on the slide. So what's happening here? Okay, my slide. Give me a minute. So I'm just going to reload this. Emeka, are you guys still with me?
Yes, I'm still with you.
Okay, so I don't know, maybe it's network issues. All right. Oh, so we're here. All right, so wow, same thing. Okay. All right, so we'll just go with this. All right, so some advice now, some advice for doing research. Okay, so you've gotten an idea of what you want to do, of you have a problem you're trying to solve. So some advice is to one, schedule. So write up a schedule with series of milestones to be accomplished by date. So for example, if you have an idea that you want to work on, so you can give yourself a schedule. You can give yourself like a month and say, okay, in a month time, I want to be done with this paper. So you set series of milestones, maybe by weekend, by social weekend, I should be done with my abstract, I should be done with my introduction, I should be done with the analysis. So set a schedule. Because one thing I noticed is that if you don't set a schedule, you will keep procrastinating and the thing keeps elongating. I think this has happened to me. I have like two research work that I've kept procrastinating and procrastinating since last year, and they are still there in my computer. Why? Because I didn't specifically set a schedule for when I'm going to finish that work. So I noticed that most of the works that I have out there are works that I have specific deadlines to meet. Okay, so that gives me like the push to try to finish them. So please set a schedule, very important. Then number two, have a research question in mind. So be focused. Don't try to answer too many questions. So just be focused on a particular part and do justice to that particular part. It doesn't have to be something so big. Like for example, if you know of a dropout technique in deep learning, dropout technique is just simply a way of trying to regularize neural networks by dropping out some particular neurons, some particular layers. A very simple idea, very simple. But from that simple idea, lots of improvement came during regularization in deep learning. Just that simple idea. And a paper was written from it for just that simple idea. So you just have to focus on a particular, it could be just maybe trying to improve a loss function, just a particular thing. So you don't have to need something so big. People think that for you to do research, you need to have a big idea, and no, just have something so small and focus on it. Okay. Then number three, ask for feedback. So share the ideas with maybe your fellow researchers or people who have done these things before, and ask for ideas, ask for feedback, things, ways to go, and the rest. So always ask for feedback. Then use the hourglass technique. What's the hourglass technique? The hourglass technique is, so first of all, read wide. If you know the shape of an hourglass, it's wide at the top, narrow at the middle, and then wide again at the bottom. So what you do is first of all to read wide on what you are trying to solve. So you read different articles, different research work people have done before on what you are trying to solve. Then you come down, narrow it down to your focus area. Okay, so that's like the hourglass technique. So the next, I don't know why. Okay, so the next other advices I'll give to you is to know your resources. So be familiar with what you are trying to solve, know the resources, know the researchers in those fields, try to look up on them, what have they done before, and things like that. Then cite sources properly. So during this process of trying to know your authors, know your read the research paper, please ensure to take a note of these authors. Ensure to cite them properly. Very, very important. Because if you don't cite somebody's work, it's very, very bad. Okay. Then the next one is get familiar with a style. There are different styles of writing. There are different outline of writing. Most of the time, it's going to be dependent on the publication or the journal you are submitting to. They will have a particular style, but these things are not too different. There are still some common grounds between all these um, journals and the rest. So be ethical, avoid scientific misconduct, do not do fraud, do not fabricate data, do not plagiarize. If you are going to be lifting a content from somebody's work, please cite the person properly. Research takes time, and please don't plagiarize. Very important. Okay, so I'm really going to move to the next one. Okay, so sample research paper. This is just like a sample of all the sessions in most of the research paper you'll be seeing out there. So you have the abstract. The abstract is like a full summary of your whole idea or your whole solution. So most of the time, your abstract is going to come at the end of your research work. Okay, so your abstract is like the first part. So it's going to like an overview of everything you did in your paper or in your research paper, including your results, summarized, very brief. Then you have the introduction. Introduction is when you are trying to tell us about the problem. Okay, so you are introducing people who have done some work on it, the problem. Sometimes literature review can also be here, where you talk about what people have done, you summarize their work, their ideas, and the rest. Then background is like most of the times the technical is explaining the technical details behind how these things work. So for example, if you're writing a research on neural networks, your background might include the layers, how they work, activation, functions, types of neural networks, so some technical mathematical details behind what you are researching on. Your methodology is where you talk about your data that you are using, how you analyze it, what you use, then your experiment, the process of carrying out your experiments, what frameworks you use, and things like that. That's what you have in your methodology. Then for your results, you talk about explain what you came up with, your ideas, what are your solutions that you've came up with, what is the solution, or what is the result of your experiments. That's what you talk about in your result. Then you also discuss your result. What does the result mean? You can't just be showing us charts of results. What do they mean to us? Okay. Then you conclude, and then always put your references. Okay. So move on to the next one. Now, once you are done with this, how do you publish your work? Okay, so there are different ways in which you can publish your work. There are full peer-reviewed journals, there is partial reviewed journals, and there is preprint repositories. That's what I like to call them. Okay, so for full peer-reviewed journal, these are like top journals where in a particular field. So for example, you have journals that accept research from computer visions, journals that accept research from data science and machine learning. So I'll show you the list of all the journals in the next slide. So for these ones, you can actually like submit to them the research work, and they will do something called a full peer reviewed, where they will share your research work with other scientists, other reviewers, and these guys are going to go through it, they're going to dig through it and try to look for some loopholes, mistakes, areas of improvements, and the rest. So it's very competitive and it's very tough for you to get your work accepted in a full peer review journal. So, but once your work is accepted, it means it's ready for people to use. Okay. So then you have partial review journal. These are journals where you can submit your work and they are reviewed partially. Why? Because most of the time it takes time for full peer review journals to accept some work. And there are lots of good works out there that some journals will refuse, but it is so good that people are even citing it, people are even using it, people are referencing it. So instead of waiting for full peer review journals, which happens maybe sometimes twice in a year or once in a year, people like to submit to these partial review journals where they just quickly go through it and put it out there, and people can use it, people can cite it. Okay. Then there's a preprint repository where you can just put your work there. There's no need for reviewing. You can just put it there. People can look at it and the rest of that. Okay. So for example of popular top full peer review journals, you have in AI, data science, and machine learning. These are all listed out here. You have NIPS, Neural Information Processing Systems, are top conferences. If you can get your work published there, you're good to go. Okay. So the list is out there. You can go through it. Then you have some good partial review journals. You have archive. Archive is very good. You have lots of preprints on archive. People, you can go there and see lots of work that have even not been published yet, but people are already referencing them, people are already reading, people are already using their results. Okay. So archive is a very popular place there. It's not full peer reviewed, it's kind of partial. Then you have academia. I think academia, they don't review, so you can just upload there. People can read and use. ResearchGate, they allow, it's kind of both ways. You can ask for feedback from your papers, and you can also just publish your paper, put your paper there, and people can go through it. The other things that you can also do when you are done with the research work is to blog about it, share it on Medium, share it on Twitter, share on LinkedIn. You never can tell. Somebody might be interested in it. Somebody might use it, even though it's not published yet. So talk about it yourself. Okay. So the links to these review journals are there in the slides, which you can also use. Okay. Then, so final words is to start writing now. Just start writing, because if you're already doing cool projects, you're already doing analysis, you're already doing gathering data and the rest, you're already doing research. So the best thing is to just put it into writing, following most of these steps. Okay. So start writing now. Then apply for research intern position if you are interested. Okay. You don't have to be carrying the title of researcher before you can do research. Anybody can do research. Okay. And if you're not good at writing, you can team up with people who are good at writing. So you can carry out most of the research you see. Not everyone is going to write it. So you can team up with a group of people and you can carry out the analysis and they can do the writing and present the results. So I would love to see lots of research coming from Nigeria. please start doing research. Okay, so then get research mentors. Okay, people who are already doing these things out there, reach out to them. How are they doing it? People who are doing good work in the field you are interested in, reach out to them. How are they doing it? Okay, so they will guide you, they will mentor you, and the rest. Then lastly, pick a field and focus on it. Please be focused. There are lots of things that can distract you in AI and machine learning, lots of different distractions, but please just be focused. Pick a field and be good at it. So if you are doing cool projects, you're already doing research. So I would love to see good work from everyone that's attending this session. Please, I want to see your research work. If you have a cool idea, start doing it, start writing on it, and let's put Nigeria on the AI map in the world. Okay? That's nice. So that's it from here. So I would love to answer some questions. So I'm currently looking at the live chat now. I want to see if you have. I think I still have like. Emeka, I don't know how many minutes do I have for questions.
Yeah, you can hear me, right?
Yeah, I can hear you clearly.
You have like 5 minutes for question.
Okay. So everyone, I have 5 minutes for questions. So I'm going to be taking your questions. So yeah, question time. Let me see. Let me look at the YouTube live. Okay,
Yeah,
thanks. I'm still waiting. I'm looking at the YouTube live, so if you have questions, and I believe there's a kind of a lag, maybe like a 2-3 minutes lag. So I'm still going to wait and. Okay, so the slide, Emeka, you're going to share the slides with them, right?
yes, I'll share the slide via Twitter.
Okay, cool.
Yeah,
Okay, it seems there's no question. So I'm good to go, right?
yeah. I think if they have any question, they can always, chat you up, send you a DM,
Yeah,
and you know,
yeah. Oh, okay,
exactly. Okay,
cool.
great.
All
That's
right.
an amazing presentation from Rising. Rising, thank you so much for the section today, and we really appreciate for the knowledge you have shared. I
Thank you
mean,
very
that's
much.
really amazing. That was $1 million, especially Mr. Nakas. Exactly. So, thank you so much, Rising.
Thank you.
If we have any question, you can always reach out to Rising on Twitter at Rising Odegba, right?
Yes, Rising Odegwa.
Great. At Rising Odegba.
Okay, someone
And
asked a
we'll be
question. I don't know if
sharing.
I can quickly answer that, Emeka. Someone asked a question.
Yes, you can.
Okay, so the question is, um, so which one among the three is the best for an upcoming AI developer? Okay, so he's talking about the journals where you have full peer review, partial review, and preprint. So the idea is to start with preprint. So if you have done a research already, you have the paper already. Most of the time, these journals, these full peer review journals, kind of like takes time. Maybe it can be once in a year or twice in a year. So, but if you are done with your research before that time, you can share it as preprint on ResearchGate, on academia. Then you can share with your friends and your colleagues for review. So people will review it, and you can get feedback even before you submit to full peer reviewed. Because at the end, your goal is to submit to a full peer reviewed. So just start with the preprint, then go to Pasha. And from Pasha, when you've done all the feedback possible, you can now go to full peer reviewed. So I think the three steps are important. So you can start with the first one, preprint. From there, you go to Pasha. From there, then you go to full peer reviewed. Okay. Then one last question. Someone said someone who wants to dive into AI but doesn't have computer background. Okay. Yes, you don't need to have computer background, but you have to be willing to learn it. Okay, so the computer background is just most of the times you do some little mathematics, some statistics, and the rest. So even if you don't have background before, you can still learn it now. It's not too late, and these things are not too difficult. It just needs commitment and time. Okay, so I think that's all. Thank you all very much. Emeka, over to you.
All right, great. So I think any other question, you are going to answer that on Twitter.
All right,
So you
no
could
problem.
just highlight the question and yeah, that'd be great too.
All
Okay,
right.
so we're going to move on to the next section. So the next section is for people who want to build their skills in competitive data science. They want to actually participate in competition in Cargo, Zindi Africa, and other open data science competition platform. So we are going to be having Nasri and Tunde that will be taking that section. Nasri is very good. Yeah, he's an active calculator and an active Zindi ambassador. So he and his teammate are going to be taking this section. Tunde, are you ready?
Of course, I am.
Oh, great. Okay, so Tunde, over to you.
Okay, hi everyone. Can you all hear me?
Hi, yes, we can hear you. You can begin.
Okay, good. Uh, I'll be making this presentation on behalf of Nasiruddin Rahim, a good colleague of mine. Due to some certain reasons, he won't be on place, and so I'll be doing that on his behalf. Now, I'll be talking on the competitive data science and machine learning as a core front, and then briefly we'll be looking into this uh, agenda as a slides. Okay, these are the agendas we'll be moving on with. The likes of why participate in data science and machine learning competition platforms for data science and machine learning, exploratory data analysis, goal and baseline submission, how to win as a competitive data scientist. So all this in a brief of time, I will be jumping into all this and making it so clear for everyone out there so that you could be one and make yourself better at the same time. Okay. First, let me just give a brief description of what is really going on in this sector of being a competitive data science and real life projects as a whole. So the question is, what are the similarities between data science competition platforms to what data scientists do in real life data science projects? There is this a statement from William Chen said, data science competitions optimizes for perfection, while data scientist projects optimizes for impact. What does that mean? If we're talking about being a competitive data scientist, all your focus on the model is towards the perfection. Working with the metrics you're given to, all you need is to improve the score, make it better on leaderboard, and make it outstanding. And being a data scientist working on a real life project, what you focus on is the impact. We are not after perfection here as being a data scientist. And why does that really being the concept? Competitions, based on your experience, we observe that your EDAs or your statistics analysis, they are not used in the final judgment. All they want to see on the leaderboard is the score. And based on that, I actually made a brief description on his behalf. Now, it said, build a perfect model with as much time as you have. Being a competitive data science, there are two different things you should understand. Your goal is different from real life projects. And one of it down there is for a competitive data science, you build a real life, you build a perfect model with as much time as you have. What does that mean? With the time constraint you have, all you have to focus on is to create new features, increase the performance of the model, check the score often and often, and make it better based on your insights. And comparing that to real life data science projects, what they do is they build an impactful model that consider time strengths and other priorities. What does that mean? In real life projects, you have to follow the business insights, and all your results and or better still, all your insights are should be a function of what the business wants. And at the same time, you have to produce your results. Yeah, we are not after, we are in real life projects, we are not after a perfect model. All we are after is build an insightful project that would actually liberate the business. But for competitive data scientists, all we are after is the perfect model. That is just the basic difference in that aspect. And looking at the high CV score, that is the success in competitive data science. The main goal is to have a high CV score, irrespective of your intuition, whether it is right or not. Your focus is to have a good CV. Then talking about real life projects, improving products and services of business is the success. Yes, you might have a low CV, or better still, let me say, you might have a low CV compared to what we might build in competitions. But in as much as liberating business, we are good to go. In a real life project, you can have an accuracy of probably 70 or 60%, and it is ready for deployment. In as much is providing insight and is giving liberation to the business, we are good to go. We don't really have time. We don't really focus on the high CV score. What is there is, can we really give insight to what we've built? How does we interpret that? And that's based on the interpretability. In competitive data science, interpretability has no importance. Take it or leave it. We don't care about how your model works. All we have to do here is build a good model, increase on your score, and make it better than the way it is. No interpretability here. What I mean by that is that how your model is working, we don't care. All we care is to see your model having a good score and generalizing on the leaderboard. That is how a competition works. But in real life projects, it doesn't work that way. Interpretability is highly important and intuitive understanding. This is why the likes of you start to understand a problem as a whole, then you generate a hypothesis, either whether it is true or not, you generate it, then the hypothesis leads you to the analysis whereby you talk about the univariate, bivariate, and the likes. So what makes these two field, or let me just, what makes these two field tends to be similar or tends to be a little bit of difference is that their actions towards the performance are different. What I'm focusing on competition is different from what I'm focusing on real life projects. So now the question down there is that, then why should I compete? There are valuable reasons for you to compete. Uh, in competitions, you tend to learn from the data structure, because there are times that you hardly see those kinds of data in your real life. And one of the best ways to improve in this your data analysis skill is to work with complex data, work with structured data and unstructured data. See how things works. Get how to query data structure you haven't seen before. And in competitions, that is where you can really see more of it. Now, going to the next slide. Why participate in data science and machine learning competition, of which I've given a brief description over there. Experience growth in working on varieties of data from both structured and unstructured. In this part, we tend to observe that working with varieties of data in competitions, this tends to be faster than taking a course. When you're participating in data science competition, the rate of learning tends to be more faster than taking a predefined course. Yes, based on my experience, we have learned so many things on competition than going through a course. And that's one of the benefits why you should participate in data science and machine learning competition. And also, you learn from industry experts for rapid knowledge. What does that really mean? In competitive data science platforms, it was observed and it is well known that experts that are working with top companies are on the platforms. This is an avenue for you to learn from their approach. How do they address problems? because the same approach they are working with in real life problems is the same thing they are bringing into these platforms. You learn from industry experts, and it helps you increase your knowledge. And also, one thing is that when you participate in competitions, you learn by doing. Going through theoretical terms sometimes it's kind of stressing you, and it's kind of time consuming sometimes. So when you enter competitions, you learn by doing. When you see challenges, you tend to improve your knowledge, tend to improve your analytic skills by doing it, not just looking for a problem to frame or working or looking for a well structured problem. Problem are defined in competitions. There are real life problems being brought down to the platform, and from there you can learn and do a lot of stuffs. And one thing there is also is there are practical business problem and tax on the likes of Cargo and Zindi. All problems or all tax, 95% of them are from industries. They are business problems. They are real life problems that they all want a solution. They all want a best solution as much as possible. So when you participate in data science competition, you have let me say you have more ability, and you have more advantage to see how real life problems are being structured, how you can address them as a whole, and when this comes your way, it's a plus for you in real life projects, because industry experts, companies, they bring their projects down to competition platforms. So competing in data science competition is not a waste. All problems you are solving down there, they are real life problems. And one thing I would say is that it helps you to improve your portfolio, irrespective of what you had or what you will have. They help to improve your portfolio. Uh, it's an addition to you because in competitions, irrespective of your ranking, or better still, irrespective of your position, an atom of your participation is a function of what people see. And as a whole, there is a reward for everything you do on that platform. It's either the reward might be a cash of a thing, or it might be a point, it might be some presentations. Uh, like let me just make a brief example of this reward of a thing. Recently, a colleague I'm presenting on his behalf, where I am not with him, he just lost uh, $2,000 and a presentation to Addis Ababa, just because of a simple point distance, 0.005, if I'm not mistaken. So he almost got the reward, just a slight point that make him not to get it. But at the same time, he was encouraged by the platform, and I think they gave him a kind of compensation. So one of these reasons for you to participate is the reward part. Everything you're doing is not a waste. There is something in return at the end of the participation. Okay. So due to the time, let me just go through this. Now, which commercial platforms are available, and which one would I really recommend for you to be? Because there are a lot of platforms out there for data science. And but the reason why I've actually selected this tool as a core platforms, and I listed others down there, is that the likes of Zindi and Cargo have been so really intuitive, and they've really helped the community as a whole. Talking about Zindi is the first and largest data science communication platform for Africa, solving continent's most pressing challenges using data science and artificial intelligence. They are based in South Africa, and based on the results so far, I think they have more than 10,000 data scientists in the whole world. And presently, the likes of Indians, Nigerians, they are all doing well on the platforms. And talking about Cargo is the world's biggest predictive modeling platform. There is one thing about Cargo, is highly competitive. Highly competitive. I repeat, highly competitive. Because everyone down there, majority of them are industry experts. They have the likes of 10, 20, 10 working experience, 15 working experience. Imagine a beginner like me, or any other one just coming to working with guys. It will be a huge lot of experience working with these industry based experts. Though, if one thing I would say is that if this is your first time, or probably you want to participate in competitions, or you want to start working on this, these are the platforms I can recommend to you, the likes of Zindi and Cargo. And also, there are also some platforms you can also learn from, and you can also participate. The likes of Analytical Video, Machine Hack, and Hackite. And there's one thing I want you to take notes about these competition platforms, and one of them is Zindi. One thing about Zindi is that the way their competitions are being hosted is very, very different from others. And what do I mean by that? They don't just build predictive models. Like all you have to do is just build a baseline model, improve on the score. You don't care about your analysis. All you have to do is have a good ICV score. No, Zenith has been changing the world of competitive data scientists, and what they are doing now right now is that there are platforms whereby, let me say, there are sections whereby you don't just build a predictive model. All you are doing down there is to analyze, is to show insights. All they want there is visuals. They don't want a predictive model. All they want is visuals. What are the insights you draw from the visualization? What can you communicate? There are competitions like that now on Zindi. And what they are doing, and what they are doing now, and what they are trying to do is that you won't just be building predictive model alone. Once probably your solutions rank one of the top 10, you have to submit a PDF presentation file that would actually tell everyone the approach you use, how do you address these problems, and what are the intuition you built towards this challenge. It's not just like other platforms. They are making these competitions more beneficial, and they are trying to liberate it to real world projects. When you build a model, tell us the intuition behind it. How do you come across these results? How do you come across these features? What are the hypotheses you generated? Now, platforms like Zindi and Kaggle, they are now liberating those forms into their platforms now. So there is no norms of saying the things like why should I participate when my intuition or when my result is not really needed. Now everything is being in place. Okay, based on what I've said earlier, Zindi, Africa, Kaggle, Analytical Video, and Machine Hack, you can just go ahead and look through them later. So now let me just go to the goal and baseline submission. One of the goal of competition is that they don't care about your nice graphs and basic statistics. All they care is to uncover patterns that can lead to new features and feature selection. All you care for, all they care for is to have a complete code to produce a submission quickly and improve on the score. And you build and run a baseline. For example, we talk about a model like the card boost, XG boost, they are black box models. Now, what I mean by running a baseline model with raw features, based on your experience, you observe that most data sets has been featured by those platforms. So when they come to you for you to actually challenge on it, it is better to work on a baseline model. Don't delete anything, don't remove anything, just number, build a baseline model and submit, because sometimes their data sets as so these are some tricks we use in competitions. Once we see the data set or once we see the challenge itself, we don't do engineering at first. We build a baseline model. If they are missing number, we likes of using -199 backfilling and forward filling. There are a lot of techniques. So try working with complex model like neural networks. They are very good for stacking. They are very good for and at the end, feature selection and your cross validation strategies is very, very important. Now let's go to the last section here. Based on what I've said earlier, you've been able to grab. I think if it's an atom of information. Section. Let me just give a brief things of how to win as a competitive data scientist. What you should have in mind is that do write a clean code which could be reused in the future. Competitions tend to be similar. They might be the same, and sometimes they might be the same, but the data structure is different. They tend to be similar. Once you see those challenges or how the problem is being defined, you can easily relate them to what you have. So all you have to just do is that bring the clean code you have before we use them so much. And also they can help you a whole lot. And try to match with other data scientists. We have more knowledge, we have abilities, we have different styles of addressing problems. So when you meet or when you merge with data scientists on the platform, that tends to give you an advantage of winning in a competition. And also generate different ideas and discuss them with your teammates, and learn to read papers and their implementation. Like Ryzen have said earlier about research papers, learn to read papers. Those papers, they let you understand what is really going on the algorithms, how you address problems, how you make your analysis and the likes. And lastly, one thing I would say is spend much time as possible to practice and learn from winning solution. Your time is very valuable. Spend much time as possible to practice. The time you spent, the quality time you spent is a function of outcome you get. Take your time to practice in competitions. Take your time to join competitions, even though it is probably once or twice in a month. Do. The reason for that is that in competitions, there are crazy data structures, there are crazy challenges that you have to call some queries that you can hardly come across them in real life projects. So participating in data science competitions, you tend to work with different data sector, be it agricultural, engineering, education, any types, any kind of data. Participating in competitions will help you to have access to those data and how you can work with them. So to just round up, there is this statement of the thing, or better, there is this popular notes by Olariwaju Imboke. He said, "Data is the new oil, and I am working in an oil company where nobody is drilling." Oh, this really drives me all the time whenever I actually read it, because it's a statement of fact. Being a data scientist and at the same time competing, it's nothing to do with the passion of me working in an oil company where nobody is drilling. So I think I've been able to actually give insights on how to be a competitive data scientist and actually leveraging those differences between real life projects. Okay, uh, thank you. I think I'll be handing this over to the convener, and if there are questions, I'm here to answer.
A great presentation from Tunde. Thank you so much, Tunde. We
Okay.
really appreciate the knowledge they've actually shared to us. And I mean, competitive data science is where the money flow like gas. Exactly. I mean, you win a competition, you get about $3,000. That's like a huge amount of money. In Nigeria, that should be around 900K or so. That should be around 900K. Imagine you win 900K for just a competition. I mean, I'm very sure that competition, maybe you wouldn't spend more than a month in it or so. Yeah, at least a month should be okay. So imagine you actually working for a month and then you're earning 900K. Like 900 good K, that's a big amount of money. So if you want to get rich young, you want to get rich young, just participate in competitive data science. And trust me, you make cool money. Cool money. Exactly. Okay. So thank you so much, Tunde, once again. And we really appreciate the knowledge you've shared to us. And I want to thank everybody who participates in this. And I'm sure that people learned one thing or the other. So what you can do is actually to tweet about what you've learned and tell the world what you've learned. And also, I'm going to be sharing the slide, Widen slide, and Tunde slide on Twitter. So you can always go check it out. And this recording will be on YouTube. So you can always rewatch it. And yeah, so basically, that is all for today. So we are going to meet same time, same area. I'll be sharing the link for tomorrow's section on Twitter too. So just follow up on Twitter at Nigeria AI. And for those who register, will be getting the email. We'll be getting that email for the link for tomorrow's section. Okay, so thank you so much for attending once again, and I look forward to see you at the top. See you tomorrow.
Yeah, you're open ready.